I hope we can do this kind of problem. I have plus q here. So they are separated by a distance d, and at a distance z above the midpoint between them, what is the electric field? Isn't it? That's the question. How do you find electric field? Electric field due to this one is in this direction. Electric field due to this one is in this direction. Am I right? Magnitudes are same. Now what would you do? So this is d by 2. This is d by 2. Isn't it? This is E. This is E. Magnitudes are same. Am I right? Magnitudes are same because this distance is same as this distance. Isn't it? So now let me take this one as R. R here, R here. What is the electric field? 1 by 4 pi epsilon naught. Speak out. Q by R square. That's it. Okay. So where R I can write as z square plus d by 2 the whole square under root. Isn't it? According to Pythagoras theorem here. While adding vectorially, okay, just split the component. Don't you remember that one in class 12th? You have done like that. Okay. So make take the horizontal component, vertical component, and add them. That's the best way. Okay. So one more way is you can take this theta and you can find that one, isn't it? So that's not necessary here. Okay. So take horizontal component. What is the horizontal component? Now I have to define theta here. Am I right? Before getting into horizontal component, what shall I write? Let me define. Which one is theta? This one has theta. Is that okay? If this is theta, then this should be theta. So this is also theta. This should be theta. Then look at here. Horizontal components are E sin theta. E sin theta. So this horizontal component again E sin theta. This horizontal component will cancel out with each other. Isn't it? So now vertical component, what are those? E cos theta, E cos theta. E cos theta by this one, E cos theta by this one. There is 2 E cos theta. That will add up. These two will get cancelled out each other. So these two will vertical component, or you write E cos theta twice. Is that okay? They will add up. Vertical component will add up. Horizontal component will cancel out. Am I right? So now whenever you add any vector, A is equal to AX x cap, B equal to BX x cap plus BY y cap. When you add them, what would you do? You add the component. That's what I have done. Is that okay? That's very basic rule. Am I right? AX plus BX into x cap plus AY plus BY into y cap. That's what I have done. So, or if you need still more clear way, so write this one as EX, EY like that. I mean, so suppose, wait a second, let me just write that one. And let me write this electric field vector, this vector, okay. Let me call this one as E1. E1 vector is equal to E sin theta. So let me choose this one as x axis. This one is, he has already taken z axis, z cap here, x cap here, okay. E sin theta into x cap plus E cos theta into, I mean, if you need pure vector algebra, you can go like this, isn't it? So E2 vector, what is this one? This vector. How do you write? E sin theta minus x cap. Am I right? Look at here. This projection is along minus x cap. Minus x cap. So plus E cos theta plus z cap. So check it out. Now vectorially add them. What would you get? This will get cancelled. This will be, yeah. So resultant electric field, that's equal to, so 2E cos theta along z cap. You got net answer, okay. And practice in this way also, because most general, am I right? That's the most general one. But after practice, you should not do like this, okay. You have to say horizontal component cancelled out, vertical component added, net electric field is along this direction, z cap, okay. Net electric field is along this direction, that magnitude is 2E cos theta. E cos theta from this one, E cos theta from this one. So now, again, I have to write that magnitude of the resultant. Yeah, so 2E cos theta. How do you define cos theta? Theta is what we have defined, remember. What he has given, plus q d and z. These are the parameters he has given. You have to write in terms of that one, isn't it? What is the cos theta now? Z by r, adjacent side by hypotenuse. So that's why that's equal to z by root of z square plus d by 2 the whole square. So when you substitute your resultant electric field, that's equal to 2 times E is 1 by 4 phi epsilon naught q by, so this one I think you will get z square plus d by 2 the whole square whole power 3 by 2, check it out, and z here, z because of this one, qz. Yeah, speak out. 2e cos theta. Over. Now one thing here is that what you have to practice here is, now look at here. So take z too large. Then the d will be very small. When you look at this configuration at a very large distance on z axis, what would you see? You can't differentiate these two. You will see 2q charge here, am I right? When you see the same configuration from a very large distance, you can't differentiate, they are separated, isn't it? So then what would happen if z is too large? Can I neglect this one? Isn't it? So now, so ER vector, that's nearly equal to, so 2 by 4 phi epsilon naught, so q z by z cube, what is this one? Z square, z cap, look at here, do it yourself. What is this one? This is the electric field at a distance z from the 2q charge along z axis, isn't it? So try to have this idea, because sometimes you can eliminate options, not answers. Sometimes you can eliminate options. Is that okay? Using this kind of idea. Is that okay? Now again in the outside problem, he has given change one charge to minus q and do the same thing. Okay, your electric field will be like this. So resolve the component. Again now horizontal component are going to add, vertical component are going to cancel out. Just do that one, other part. Next one, example number 2.2. You have to be very good at coordinate geometry, okay? Example number 2.2. Find the electric field at a distance z above the midpoint of a straight line segment of length 2l. I have straight line segment of length 2l, okay? Of length 2l. Of length 2l. So at a distance z above the midpoint again. At a distance z above the midpoint. Okay. Total length is 2l here. And that is containing uniform line charge. Uniform line charge. He said uniform line charge lambda. Uniform line charge means, how do you define line charge density? dq by some dl. Am I right? That's how you have defined. But when it is uniform, you can write as total charge by total length. This is the total charge. So total charge divided by total length. Okay, we may need to use that one sometimes. Is that okay? And that is constant. That is constant. Uniform line charge means, uniform line charge density means it is a constant. Is that okay? So now look at here. Obviously, what is our idea? Whenever we have a line charge, so divide that line charge into one small tiny part, so which contains charge dq, and that distance is, let me call this one as dl or dx here. Okay, here I have written dl. but I better to take x because so that I can take this one as x-axis. Am I right? I can take this one as x-axis, dq by dx. Is that okay? In place of dl, I am writing dx. So I hope you have no issue. So now the charge corresponds to that one is dq. And dq and dx are related by dq by dx is equal to lambda, that's equal to constant, or dq is equal to dx into lambda. Learn this integration. Now, due to this small elemental charge, electric field at this point, I call this one as, this is the point of interest, okay? So, dE, I call this one as electric field dE. Is that okay? What is that dE? Now look at here. I have to write, this is my source, this is my field point. What is my italic R? This was my italic R. So now I forgot one more thing. I have written normal R earlier, am I right? Earlier I have written from source charge to field point, I have written normal R. Don't write that one because you will end up with confusion, okay? Follow his symbols, italic R. Are you getting my point? Plus Q, whatever this distance, I have written R. Don't write like this, write italic R only. Is that okay? Write italic R only, okay? So, unnecessary confusion. So, always source charge to field point, italic R. Is that okay? Yeah, anyway, that's a solved example. Look at that one again, okay? Now, let me take, this is the origin. That's your choice again, okay? Origin is your choice. So, now suppose this is at a distance x, this dq, it is located at a distance x from the origin, and that elemental charge, it has a length dx, and dq by dx equal to lambda, charge per unit length, charge per unit length. Is that okay? So now, what is the next step is to define dE. Look at this one carefully, okay? I need these ideas later. Now, this is actually simple problem. So, ideas are, look at here, what is this one? 1 by 4 pi epsilon naught dq divided by r square into r cap. Earlier, we had only two components in space. We haven't talked about this one, am I right? We have taken magnitude and we have found the resultant, isn't it, earlier. So, but here, I have to integrate, am I right? So, now here I can't, so take individual vector, its component, and I can't add it out, remember, it would be very lengthy step, isn't it? So now, if you just, so how many elements you have, how many elemental charges you have along this one? Infinitely many, isn't it? That's why you can't add infinitely many vectors, am I right? So earlier we had only two vectors you have added. So that's why the process is integration. But when you get into integration, look at here, your italic R cap is variable. Isn't it? So, I mean, if you just move this dq, your R cap is variable, okay? There is other way of doing that one. What is that one? Taking vertical component, horizontal component will get cancelled, isn't it? For one element here, there will be corresponding element here whose horizontal component will get cancelled. That's other idea, okay? So, let me do in his way, that's also needed later, okay? That idea is needed. Whenever you end up with a vector in an integration which is variable, so convert that vector into constant vector, isn't it? You can't add up those vectors, am I right? When you have continuous integration, you can't add up those vectors. Are you getting my point? You can add up scalar, you can have scalar integration. So vector, you have to follow rules, am I right? So that's why you have to avoid that one. That's why the idea is writing this R cap in terms of x cap and z cap. Is that okay? Writing that R cap in terms of x cap and z cap. That is the best idea, okay? Again, you can do in other way. Let me just show that one. But let me just first try with his way because I need that idea. Now, what is total electric field? That's equal to integration of dE vector. Isn't it? If you have two vectors, you can use your law of addition of vectors. Am I right? But integration, you have to convert that one into scalar integration. Isn't it? Now, how do you write R cap? Now look at here. I am going to define R cap or R vector. This is my R vector. Am I right? Now I am going to define Z vector here. Z into Z cap. Can I write like this? So this vector has x into x cap. Are you getting my point? Can you see this one? This vector, this vector. Now what is the relation between x cap vector, z cap? That's our choice, okay? These all vectors that I am defining that one, okay? Now look at here. Can you write italic R in terms of z cap and x cap? Z cap minus x cap is italic R cap. Look at here. Z cap vector minus x cap is equal to italic R vector. Check it out. This one minus this one. So this vector plus this vector, am I right? So this is x into x cap, ulta minus x into x cap. Is that okay? So now this is your italic R vector. What is it? Italic R cap now? Is equal to z into z cap minus x into x cap divided by root of z square plus x square, modulus of that vector. Isn't it? Now, what is the idea? Idea is to write that variable, the unit vector which was variable throughout the integration, writing that one into constant unit vector. Z cap and x cap will not change. Isn't it? So that's the main advantage of our Cartesian coordinate. Our unit vectors will not change the direction. Once it's set, it is set throughout the problem. Isn't it? So that's why, look at here, electric field is equal to 1 by 4 pi epsilon naught dq I can write as lambda dx, okay? dq I can write as lambda dx, lambda I can take outside. So dx divided by r square. What is r? What is r square here? X square plus z square or z square plus x square. Just check it out. Yeah, obviously. We are talking about plane. We are talking about the plane. Look at here. I mean, if you can just bend this one, then you can construct a plane. You can bend this whole story. There are problems like that outside this one. Okay. So he's putting this answer into one square loop of wire. Then you have to bend this one and you have to think over it. Okay. So try to solve them. You will understand. Now just let me do this integration. What is r square? What is r square? Pythagoras theorem. Z square plus x square. Z square plus x square. That is r square. What is r cap? Z into z cap minus x into x cap by root of z square plus x square. Now integration with respect to x dx, it automatically becomes integration with respect to dx. Am I right? So now look at here. How x runs from now? What is the range of x? You have origin here. Now you have to sweep your dq from here to here. Am I right? When dq is here, your length is plus L. When dq is here, your length is, with respect to this as the origin, this is minus L, this is plus L. Isn't it? So minus L to plus L. When x ranges from minus L to plus L, you are sweeping throughout the length. Isn't it? So now look at here. Lambda by 4 pi epsilon naught. So z is constant. I can take that one out. Z into z cap. Z cap is also constant. Look at here. Writing this one like this, because these vectors are constant, you can take outside the integration. That was the idea. Okay. Z into z cap, integration minus L to plus L. What is this one? Dx by z square plus x square whole power 3 by 2 dx is also there, minus x cap is outside, x is variable, so take it inside, but x cap unit vector, that is same, minus L to plus L, x dx divided by z square plus x square whole power 3 by 2. Check it out. So check it out. Can you see this part? Now what is the second integral? Symmetric limit. Because why? Odd function. x square is there, x is there, odd function, symmetric limit vanishes. Obviously, look at here, all of this electric field vector, those horizontal component will get cancelled out, vertical component will get add up, your resultant vector should be along z cap, it will remain. Okay, let me do the same thing in a different way. So lambda by 4 phi epsilon naught, so z into z cap, I better write this one directly. I have given, this will come very frequently, am I right? And we got the same integral somewhere else. So you better remember directly. What is that one? 1 by root? 1 by root or minus 1 by root? X by root. X by root of? I mean integral answer. Z square plus x square running from minus L to plus L. Check it out. Outside? One more z. 1 by z square. Why? Okay, 1 by z square. Like that? Is that correct? Or what is the substitution? X equal to z. Z is constant. Z is not variable. X equal to z tan theta. That's the substitution and you have to do that one. So try that out later. Yeah, am I right about this one? Yeah. So now your electric field, that's along z cap, no doubt. So lambda by 4 phi epsilon naught 1 by z. 1 by z. Yeah, I'm getting little. So put x equal to z tan theta. That's your standard substitution. So then what would happen? Z square plus z square tan square theta. Take z square outside. That becomes secant square theta. 1 plus tan square theta, secant square theta. Secant square theta raised to 3 by 2. Secant cube theta. Again, you have to substitute for dx. Integration by substitution. So try that one. If you can't get that one, let me explain. Is that okay? Again, what I suggest here is, don't change the limit. Okay? Don't change the limit. Keep the limit as it is. So do the integration. After that one, again convert in terms of x and z, and then apply the limit. That's what I suggest. When you make this kind of substitution, you have to change the limit also. Okay? Don't change the limit. So obviously here you can change the limit, but don't go for changing the limit. That will be theta equal to inverse of something, tan inverse of something. Avoid that step. So do the integration. Ultimately you will get in terms of theta. Convert that one into z and x. Again then apply the limit. Okay? So do that one yourself. So 1 by z, upper limit minus lower limit. I think 2L whole divided by root of z square plus L square. Check it out. He's writing this one as 1 by 4 phi epsilon naught lambda into 2L divided by z into root of z square plus L square along z cap. So this is pure vector algebra way. Is that okay? What is the other one? Write it as dE. You can define theta here. dE sin theta. dE cos theta. Am I right? That so wherever you take the segment, remember that dE cos theta component is going to get added. Am I right? But dE sin theta, look at here. For this element, you have dE sin theta like this horizontal component. So there will be what you call another element here at the same distance. So in this direction, which will cause again so horizontal component equal and opposite. Horizontal component will get cancelled. Vertical component will get added. You can integrate dE cos theta then you can put Z cap. Isn't it? Because vertical components are getting added. So this is how you have to do. You have to do in the exam, okay? Not that way, but that idea is needed. That's why I am just introducing. Whenever you have any vector which is variable throughout the integration, what would you do? Try to split that vector into constant unit vectors. Okay, that's the idea. But so practice in this way, isn't it? Are you getting my point? So now look at here. There are two ways of doing that one. One is you can take dq here. You can take again dq here at a distance, same distance x from here. You can take again so from this one de. Okay. So again theta here, same theta, just like you have taken earlier. Am I right? So plus q. Now take dq here, just symmetrically. So now 2 de cos theta, that's the vertical component. Then you have to integrate from 0 to L. You should not integrate from minus L to plus L. Why? When you integrate one element from 0 to L, other element also sweep here, so that you are adding everything. Or what would you do? Other way. So take only one element. Wait a second. Origin. So take only one element. So this is dE. Am I right? Theta. What is this one? dE cos theta. dE cos theta. dE sin theta. And you should know how those sin theta components are vanishing. Okay. So not because of elements here, because of, for every element here, there exists other element here which will cancel out horizontal component, isn't it? So then, so you can integrate dE cos theta minus L to plus L, or you can integrate here 2 dE cos theta at 0 to L also. Both are same. Your integral is even function. Look at here, you can write it as 2 times 0 to L. So this whole thing is a even function. So minus L to plus L, isn't it? If you take dE cos theta, you have to integrate from minus L to plus L. So you can write it as 2 times 0 to L. Look at this one. This whole thing is a even function. You can check it out. Okay. So both are same. Integrating 0 to L, 2 dE cos theta by taking two elemental charges and resultant vertical component, or taking only one elemental charge and taking its vertical component and sweeping that one throughout that one. Is that okay? So now, speak out. What is dE? Lambda by 4 phi epsilon naught. Lambda by 4 phi epsilon naught dx divided by z square plus x square, z square plus x square. What is cos theta? X divided by italic r. Am I right? X divided by italic r. X divided by, no, not x divided by italic r. Cos theta, z. Am I right? Adjacent side by z divided by italic r is again z square plus x square under root. You got the same integral. You can check it out. Same integral. And do in this way. But take that idea. Speak out. You have to feel that integral. Is that okay? How it runs like that. If you take two elemental charge, if you take 2 dE cos theta, when you run your integrals from 0 to L, so this simultaneously this will run from 0 to minus L, like this. When you take only one elemental charge, if you write dE cos theta, so now you have to run this one throughout this length to get net electric field along vertical direction. Okay. So again, everything can be geometrically interpreted. Think over it. Any question, post that one quickly. So try this one yourself again, okay, on a fresh page. Is that okay? On a fresh page later. Now you can do example problem number 2.3, third problem in the second chapter. You have a line segment only one side and you have to integrate only one side, okay. So now while doing this kind of, now look at here, you need this idea, okay. or you can do that one also. So both x and z component will be there. Check it out. Okay, try to do that problem. Problem number 2.3 in my book, in the new book, third problem in the second chapter. Okay. And one more way is writing dE vector. Writing dE vector, dE sin theta into minus x cap, am I right? In this sense, plus dE cos theta into z cap. That's also okay. Everything is same, isn't it? Again, while doing this one, this integral will get cancelled, vanished out. So let's look at here, x by root of z square plus x square. X by root of x by r, that's your sin theta definition. So that's that part, this part actually. You can do like this also. So try in a different way. Same problem. Yeah, quickly. Yeah, wait a second. Let me take again last answer. What was our last answer? 1 by 4 pi epsilon naught lambda into 2L by z into root of z square plus L square along z cap. Now look at that whole line segment from a very large distance z. Okay, z is too large. Then you can neglect L, isn't it? If you neglect L, your electric field at a very large distance 1 by 4 pi epsilon naught. So lambda into 2L divided by z square approximately if you neglect L square. When z is too large compared to z square, L square you can neglect that one. Root of z square, z into z square into z cap. What is lambda into 2L? Any idea? Total charge, am I right? This length was 2L. Lambda was charge density. So total charge by total length. Lambda into 2L is your total charge. Uniform charge density. He defined like that. Am I right? That's why this is your total charge. 1 by 4 pi epsilon naught. So total charge divided by z square, z cap. What is the interpretation? When you look at the configuration from a very large distance, you will feel that the total charge, point charge is it is situated at the origin. So you are at a distance z from the origin. Origin, suppose very large distance z. If you are looking at the configuration from a large distance, you will feel like that, isn't it? You can use this one to eliminate options. Yeah, now do problem number 2.4. 2.4 means second chapter, fourth problem, okay. Now that is a square loop. You have to find electric field at the above, exactly at the, at a distance z above the center of the loop. Now you have to use the answer of this one. You have to use this answer, okay. But that's purely geometrical problem. You have to use this answer. You can use this one, but you have to think geometrically. Because you will not get one plane, okay. So this problem is not on a one plane, okay. You have to think over it. So try to do that one. So 2.3 and 2.4, can you do? And we need to do 2.5 also, 2.6 also, 2.7 and 2.8. You can skip that one because that can be done by so that can be done using Gauss law very easily. Is that okay? Other two problems. So here that integral would be lengthy. Yeah. Any question? Try 2.3 and 2.4. Third and fourth problem. Let me just go to next problem, 2.5. I have a ring here. Okay. I have a ring here with uniform line charge density lambda. With uniform line charge density lambda. Let me read out the question. Find the electric field at a distance z about the center of a circular loop of radius r carries the uniform line charge lambda. Radius is r. At a distance z above, okay, at a distance z above, it is glued with a charge of uniform charge density lambda. Is that okay? Now, how do you write that lambda now? Again, dq by dl like that, am I right? dq by dl like that. Then total charge, but the total length 2 pi r. 2 pi r. Okay, keep it one side. That's constant. Lambda is constant. Okay. Now look at here. It's exactly same as our earlier problem. Now take one elemental charge here. So dl correspond. So elemental length corresponding charge is dq. Again, take one more element exactly opposite to this one on the circular loop. Okay. So again, this also dl, length is dl. So charge is dq. Okay. From this one, electric field generated is in this direction. Let me call it as dE because elemental electric field, elemental charge, small amount of electric field. So similarly from this one, again dE, isn't it? Now when you sweep these two, look at here, when you sweep these two, what would happen here is, this theta will not change, okay? This theta will not change. Now this is my italic r. Can I take this one as italic r? Italic r will not change, look at here. When you sweep those things, that will become one cone, am I right? This distance will not change. That's not variable. You can keep it and you can just write that one later. But you have to do vector addition, am I right? Now you got, so now don't write that one in a 2 coordinate, okay? Because when you just sweep, this not in a 2 dimensional. So remember, when you just sweep this one, this will also sweep a cone, am I right? This electric field dE will also sweep a cone, okay? So better to do it like this. Again, write this one as dE. Suppose theta is here, this is theta, am I right? dE cos theta, dE sin theta, am I right? dE cos theta, dE sin theta. I better not to take one more segment, isn't it? If I take one more segment, what would happen? This will also give dE cos theta, 2 dE cos theta. Then you may integrate throughout that one. That would be extra. Okay, wait a second. Let me not take this one. Wait a second. I take only one of them. But I am going to argue for this segment, for this elemental charge, there exists one more elemental charge exactly opposite, which will cancel out its horizontal component. Okay, now this electric field, elemental electric field, it has got vertical component, horizontal component, am I right? Now when you just sweep this one throughout the circular loop, all of those vertical components are getting added and horizontal components will get cancelled. Why? So for this element, there exists other element at the exactly opposite side of the loop, which will give again dE sin theta in this direction. I hope you got that idea. Is that okay? So that's why you can just integrate dE cos theta, then you can put z cap if you want it in terms of vector. Horizontal components will get cancelled. And that theta is also constant. Look at here. Isn't it? Theta is also constant. When you just sweep this one, theta is also constant. So what is dE now? 1 by 4 pi epsilon naught dq divided by italic r square. What is dq? Lambda dl. Am I right? dq is equal to lambda dl. That's equal to lambda by 4 pi epsilon naught dl by r square. Just substitute that one. Again, if you are not getting how horizontal components are cancelled, think over it yourself. Okay. So z cap lambda by 4 pi epsilon naught 1 by r square is also constant. R italic r is also constant. Am I right? Cos theta is also constant. What is this one? Integral of dl. What is integral of dl? I mean dl. So 2 pi r. That's it. Is that okay? Z cap lambda by 4 phi epsilon naught. Again, theta is what I defined theta. I defined italic r. He has given radius of the ring and this z. You have to write everything in terms of that one. What is cos theta? Z by r. Am I right? Z by r, 1 by r, sorry. Z by italic r square. So 2 pi into small r. Small r is radius of the ring. Okay. Now let me write it like this as earlier. 1 by 4 phi epsilon naught. So z by italic r cube. What is italic r? Z square plus r square. Am I right? Z square plus r square whole power 3 by 2 r cube. R is root of z square plus r square. Am I right? Raised to cube. Raised to 3 by 2. Isn't it? Raised to 3 by 2. Do it again. Into lambda into 2 pi r. Let me keep this one side. Why? I hope you got the idea. Why? If I put z large, lambda into 2 pi r is your total charge. You can have that approximation. Am I right? It's your net electric field. Okay. Again, when z is too large, okay, this will tend to nearly equal to 1 by 4 phi epsilon naught. Z, you can neglect r square, z square raised to 3 by 2, z cube, 1 by z square, 1 by z square into lambda into 2 pi r is q total. Lambda into 2 pi r, that's your total charge. Am I right? Do it again yourself in your way. If I? Where? Here? On this one? Then you have to make the summation. No. I mean, how many charge you put? Question comes. Isn't it? Now, if you are taking point charge, then you have to take summation, isn't it? There is no reason to go for integration. Integration is only for continuous distribution of charge. Electric field will change, am I right? This electric field for continuous charge distribution. If you have now my question, whether you put 100 charges on the circle or 50 charges, that's left to you, isn't it? Don't neglect numerator. You have to keep that one. Look at here. In this one, you can neglect that one. How do you neglect that one? Look at here. When you, that approximation is valid when you have additional term. Am I right? This is a multiplication term. Don't neglect multiplication term. That because that will decide the whole term. Actually, we are increasing only z. We are not changing r. We are seeing this configuration at a large distance z. Is that okay? But one more idea is never ever neglect the multiplicative factor. You can't do that. What would you do? Will you write 0? No. Entire thing will be 0. Okay. But when you have additive factor, now compared to this z square, z is too large compared to this one. Actually, z is too large means z is very much greater than r. How much large? The question comes. Am I right? Z is very much greater than r. That's what I wanted to say earlier problem also. Okay. So when z is very much greater than r, you can neglect this r square and you can proceed with that one. And when you look at the configuration from very large distance, you will feel total charge is concentrated at one point. That's how you get, isn't it? Yeah. Okay. Practice this one. Okay. I think in the rigid body dynamics, you will get this kind of integral. Right? We have done somewhere. We have done somewhere in rigid body dynamics. You'll get similar integral. Am I right? So dividing that one again, defining mass density. You got the same procedure. Here charge density. That's it. But here it is vector addition. Yeah. Oh yeah, if you take 2e cos theta, you can take 2e cos theta. Yeah. So actually I forgot. dq, dq, okay. dE, dE, okay. Now this is theta, this is theta, 2 dE cos theta, isn't it? Vertical component, sorry, horizontal component got cancelled, isn't it? Now look at here. Now while integrating, be careful. So now look at here. If you integrate this one from here to here, it's over. Look at here. Sweep this one from here to here, isn't it? You covered entire ring. You are taking both of them together. Same idea applies earlier, minus L to plus L. Is that okay? You can take that one, 2d cos theta, but while integrating, you are going to integrate dl, am I right? Write it as pi r, not 2 pi. Otherwise, it would be extra. Yeah. So if you take only one elemental charge, then the integral of dl, write it as 2 pi r. Are you talking about earlier problem? Okay, horizontal component. No, you have to argue. You have to argue and you have to move on. Okay. If you have taken only one of these, now dE cos theta is your vertical component, dE sin theta is your horizontal component, but you have to argue and then move on. You have to argue for this elemental charge. Obviously, you are going to move this one throughout that one. Am I right? So when you come here, you will get again horizontal component, which will cancel out its effect. You have to comment and then you have to move on. You have to add only vertical component. No. So I mean, if you have taken 2, this becomes 2d cos theta. That 2 factor came here. Now wait a second. dq. Now you have to sweep throughout that one, isn't it? Now look at here. So I mean, while integrating again, you will get integration of dl ultimately. Am I right? So while integrating, you have already taken 2d cos theta. So you have to integration of dl. You have to write as, look at here, from here to here. If this charge comes from here to here, this charge automatically goes from here to here. Only one charge. That's why you have to write integration of dl as 2 pi r, because there was no factor 2 here, isn't it? Now 2 charges right now. If one charge sweeps like this, other charge will automatically sweep other part. That's why integration of dl, you have to write as pi r, not 2 pi r. So other factor 2 is already here. It will take care. Okay. Do in both way. Initially prepare to be wrong. Okay. Not in exam. Let me go for question. In a single segment, you have to argue and then you have to move on. It will get cancelled when you sweep throughout that one, or just think like that. Am I right? So when you sweep that one, your electric field will sweep a cone above. Am I right? When you sweep on the ring, your electric field will sweep a cone. Now take all vertical component, it will get added. Now your horizontal component will be on the circle, on the plane. Am I right? You can imagine like this also. When you sweep that one, if you have only one charge, when you sweep that one, all vertical component, they are along the same direction. Horizontal component of each, they will sweep on the circular disc. Am I right? Yeah. N? This one. No, you have to integrate this. So continuous charge distribution. You haven't taken Q1, Q2. You have taken DQ. So continuous charge distribution. You don't know how many charges are there. You don't know what is the individual charge like that. Okay, continuous charge distribution. You have to work like that. Now look at here. So these will get cancelled. For each and every vector here, there will be opposite vector here, which will get cancelled out. It's simple. You can think like that also. If you are taking only one charge and if you are sweeping. Is that okay? So everything can be picturized here. Yeah. If it is not clear, again ask the question. Is that okay? It's not quantum mechanics, isn't it? Let us assume, let us like that, isn't it? Not much hypothesis. Yeah. Shall I go for disk? Here what he will do in this problem is, I think he will take a ring and he will again integrate to make it as a disk. Okay, let me do in a different way. Anyway, you can, anyway you will see the solution manual, isn't it? Now you will feel like it's a disk, isn't it? Of radius, let me take capital R, radius capital R, which is containing uniform surface charge density sigma. Okay, uniform surface charge density sigma means total charge divided by total surface area. What is the total surface area? Surface area of the disk, isn't it? You can write this one as dq divided by small area, elemental area on the surface. There is a small elemental area on the surface. Now, I think I have done something in earlier. I think in case of Kepler law, we have taken that one. Elemental area. Moment of inertia itself. Am I right? I have done this one. So, in this batch, sure? Yeah. No, what I was thinking is I skipped that part. That's what I feel. This one we derived? No. No, this one we didn't derive. No, I was, yeah, I was I was in a hurry at that time. I remember only that one. Okay. Now, wait a second. So now I need, what is that one? Electric field at a distance z above the center of the ring. Okay. Obviously, you can think your resultant electric field is vertically above. Am I right? Vertically above. But I hope you know how to define elemental area in case of polar coordinate. Plane polar coordinate. How do you define elemental area? Plane polar coordinate. I need elemental area. I defined in case of Kepler problem. This is theta approximately. This is d theta. This is r. This is dr. Am I right? So this is approximately, what is this one? R d theta. R d theta. R dr d theta. R dr d theta. It's the elemental area in a plane polar coordinate. Now I am going to design or I am going to define plane polar coordinate on the plane of the disk. This is my initial axis. Okay. This is my initial axis. Radius is r. Now let me take one elemental area somewhere here. Okay. Let me take one elemental area somewhere here. Take this one, take this diagram quickly. It's better. We have done that one somewhere. Isn't it? In case of Kepler problem, while showing Kepler's second law, I think. Isn't it? Approximately, this elemental area in plane polar coordinate, that is r. So I can take it as a almost square. Approximation. R d theta dr. R d theta dr. R dr d theta. That's how we write. Okay. So now this is my elemental charge dq. Now I better to take elemental charge somewhere here because I can show the components very easily. Okay. I better to show elemental charge somewhere here. Okay, this is my dA. I have a dq here. Okay, where dA by dq, sorry, dq by dA is equal to sigma, or dq is equal to dA into sigma, sigma dA. Sigma is constant. Sigma is constant. Over. Now, because of this elemental charge, let me define electric field at this point, dE. Now, again, I'll take my earlier idea. What is that one? Let me define theta here. What is this one? This is R, okay? This is R. This is d theta like that, okay? R d theta like that, just like I have written with that. So, now if this is theta, then obviously this would be theta. So, this is dE cos theta, this is dE sin theta. I mean horizontal and vertical component because of this elementary charge. Okay. Now look at here, for each elementary charge here, there exists other elementary charge here which will cancel out its horizontal component. Okay, let me argue and let me move on. I'm not interested to write everything in a vector form, isn't it? So can I argue like that? For each dq here, you can just take one more dq somewhere here. So again, it will produce dE here, dE sin theta here, isn't it? It will cancel out its horizontal component. That's why when you just sweep this one throughout the disk, throughout the surface of the disk, all vertical components are getting added, horizontal component will get cancelled. Suppose if you take one more element here, you may get one more element here, elementary charge here, isn't it? Are you getting the idea? So that it will cancel out its horizontal effect. Okay? That's why I need to integrate only dE cos theta. I mean, integration means you have to run this elementary area throughout the region of the disk. The radius of the disk is R, isn't it? Suppose if you want to sweep the disk region, your theta should vary from 0 to 2π, your R should vary from 0 to capital R. In planar polar coordinate, if you want to sweep disk surface, okay, your R should run from 0 to capital R. Capital R is the radius, theta should run from 0 to 2π. It will sweep entire disk. Okay, this is your net electric field, it is along Z cap. Suppose let me take this is Z cap. Isn't it? Net electric field should be along that direction. Now start working out. What is dE? 1 by 4π epsilon naught dq divided by italic r square. Am I right? 1 by 4π epsilon naught. So, what is italic r? R square plus Z square, isn't it? R square plus Z square or Z square plus R square. R is variable, Z is constant. Okay. What is dq? Sigma dA. Now, if I substitute electric field Z cap into 1 by 4π epsilon naught. Sigma is also constant. Sigma is also constant. What is cos theta? Z by R, Z by italic R. So Z is also constant. By italic R square, italic R cube. I think you will get again Z square plus R square whole power 3 by 2 again. So dA, check it out. I have written directly, take one more step. Okay, so take one more step. I have written directly. Because cost of one mistake is 6 months. Okay, Z cap is equal to sigma Z divided by 4π epsilon naught. 4π epsilon. What is dA now? Write down. Actually, I should have written double integration, but I hope you now we prefer writing only one integral symbol. Am I right? So what is dA? R dr d theta. That is the elementary area in a plane polar coordinate. Okay. So divided by Z square plus R square whole power 3 by 2. R will run from 0 to capital R. Theta will run from 0 to 2π. Can you do this integral? Okay. You have to take different symbol. Be careful. dr d theta. But usually we prefer writing only one integral symbol. That's what I said. Okay. Most of the case, even in the volume integral, we prefer writing only one integral symbol. But I mean, whenever you write this variable, you should know that is, I better take pi here. Okay. Where else? Don't integrate cos theta. That would be very big mistake, isn't it? Are you getting my point? This theta was defined here. That is constant. That's not constant. That's not constant. Okay. What is cos phi? Z by r. That's equal to z by root of z square plus r square. It's also variable, but this phi is different. This theta is different. Is it okay? This phi you can write it in terms of small r, isn't it? Be careful. Be careful. Okay. Symbol. Hello. Hello. Can you do this one? I think same integral you got, r divided by this one. Two integral you got, remember, okay, this one also. We got somewhere else, same integral. I prefer this one. He has taken the ring and he integrated electric field due to ring, so that he integrated, he varied the radius of the ring from 0 to r like that. Try to do in that way also, but I prefer this one because coordinate geometry is the most general way. Okay. Now you can put r tends to infinity to find electric field due to infinite plane, that we can match with the Gauss law outcome. Okay, later. Find this answer. Find this answer. R will run from 0 to r, theta will run from 0 to 2. Obviously, integral of d theta, that will give 2 pi. You can take it out. Just r integral is remained. Is it okay? You can write like this: integral of d theta outside 0 to 2 phi, that's equal to 2 phi. Only this integral 0 to capital R needed to be done. Yeah, he has given that approximation. Let me do it later. After finding electric field due to infinite plane, we shall try to match this one, both of them. Okay. Again, take the answer. So take Z very large, isn't it? So now total charge, Q total, sigma into pi r square. You have to feel that total charge, point charge, situated at a distance Z, isn't it, from you. So that's how you feel. Okay. I mean, you can eliminate options. Okay. Try to do the approximation at the end. Okay. If you make Z very large, you will feel that this is a point charge. Am I right? So you will feel like this total charge is there at one point. You keep Z as it is, make this R infinity, you will get electric field due to infinite field. Yeah, let me do that approximation later.